Hi, everybody. We are going to really quickly talk about creating a motion map. And what a motion map is, it's kind of a way to visualize the concept of motion in like a two-dimensional area. So what we want to do to start is we need to determine where our reference point is or where our 0 point is. This is the place that we're going to call zero or the point of reference or the reference point. Okay. So that's the place that all of our motion is going to be referred to. So in my class, how I like to do it is I like you to draw an X, and you can label that X 0 if you would like to. Okay. Then what you're going to do is you're going to draw an arrow. All right. So hopefully that's this. Yes. And that arrow head there is pointing in the positive direction. Okay. Which means that if you're going towards the point of reference, if you're going backwards away from the direction of the arrow, going this way, you'd be moving in the negative direction, right? So that indicates that negative would be moving the other direction. All right. So keep that in mind. That's how you create the actual, like, I guess it's almost like the graph for a motion map, but there's no y direction. This is just kind of like the x axis, if you will. But the grid itself, or like the graph itself here, the arrow and the x actually don't mean a whole lot. It's just kind of showing you which way is positive and where 0 is in space. Okay, so using this car, we're going to show you how a motion map gets made. All right. So the motion map is actually going to show us what the position is of the car after each second in time. And how we're going to do that is use dots. So dots are going to represent the position of the vehicle at a certain time, okay, or any moving object, whatever. So at time equals 0, our car was here. Okay, so I know that looks like an oval, and that's okay. I'm just making a copy for later. All right, so time equals 0, our car's here. Okay, let's say time equals 1, our car is here, right? And then time equals 2, our car is here. And guys, I'm using this grid to help me set up the problem, right? So that it ends up coming out okay. There's not usually going to be like a grid or a graph paper. I'm being very specific with what I'm doing right now just to make sure that it doesn't show you a bad example. All right, so that is going to be where our car is after this amount of time. So how we're going to write this is we're going to go through and we're actually now going to label the time. So time equals 0 seconds, right? Is the first dot. That's where the car was before anything started, before any motion happened. Then once the car started moving, the next dot is time equals 1 second. The following dot is time equals 2 seconds. Then we got time equals 3 seconds. Then we've got time equals 4 seconds. Okay, so this is the motion of the car after 4 seconds. Now, it's just showing us the position. Now, but you'll see that these dots are equally spaced out. So this is actually going to tell us a story about how fast the car was going. So we can actually use an arrow to show the velocity of the vehicle this whole time. So arrows that you're going to put on this graph are going to show the velocity. Okay, so let's grab an arrow, and you just take an arrow and you go from one dot to the next. And I think what you're going to notice is since the spacing between all of my dots is the same, and I'm sorry they're not all vertically aligned, but it's close enough. The space between all the dots is exactly the same. So the lines, the arrows, are going to represent the exact same amount of velocity. So that's going to tell you how far you go in a given second. And it works because you know that the time interval between each dot is 1 second. So the size of each arrow actually represents the velocity because it's showing you not only the direction, but the speed. Okay. So the size of the arrow represents the speed. And again, if we had like markings on here, so if you actually did say this is like, 1, 2, 3 meters, we'd be moving at 3 meters per second. Okay. And that's helpful now because we have this grid. So if this is 0 meters and every one of these lines is a meter, then these arrows are representing that are moving 3 meters each second, right? Because each dot is 3 meters apart and they're all 1 second in time apart. Okay. Okay. Last note about this, I added some words down here for y'all to see. I took away the grid. So if one of these arrows were to be bigger or smaller, that would represent a faster if it's bigger, or a smaller, slower speed. Okay. So that's to help you understand kind of the concept of position and velocity on a motion map. Okay, so here's an example to kind of show you what I was talking about. So larger arrows mean larger velocities, right? And slower arrows mean slower velocities. You can tell the car at the top was much faster than the car at the bottom, right? Or whatever object was moving, because we've got only 2 seconds and two big long arrows, meaning it was going very fast, right? So this is our faster car. And then down here, we've got a car that took 5 seconds to get almost the same distance. And so it was obviously going slower, right? And for both of these, you can see the arrows are the same length across both these here at the top, and they are the same length down here at the bottom as each other, right? So these are bigger arrows, meaning faster, but they're the same length as each other, meaning that the speed or the velocity was the same. And then down here, these arrows are smaller, which means that the velocity was slower. And you know that this velocity is the same as this velocity, same as this velocity. It's called constant velocity. Okay. Next one. Okay, so here's a situation where a camel is an object, is some distance away from the point of reference or the 0 point, okay, and it's not moving at all, right? So what happens is you're actually going to stack the dots on top of each other like this. So it's like it's marking time, okay? It's staying in the same place. So we're just going to put the dots in the same horizontal position. There's no vertical axis, there's no vertical position that you need to worry about. We're only worried about the horizontal position, okay? So then how you'd label that is you'd say, okay, this is time equals 0 seconds. And then here we've got time equals 1, time equals 2, time equals 3. And then up here is time equals 4 seconds. So it's waiting for that amount of time. Okay. So that's how a position, an object that is sitting still would look. And you just kind of have to choose how you want to stack the dots. It doesn't matter if the dots are on the top or the bottom of the motion map. You could also put dots down here. That'd be totally okay. All right. So you could even have the dots cross that for that axis. It doesn't make any difference. The idea is really we're only visualizing it in the flat plane, the x-axis. So what happens up and down doesn't really make any difference. So if your dot's stacked up or down, it wouldn't make any difference as long as you label your time so that we all know what we're looking at. Okay, so an object can also go in the negative direction, right? So if it starts somewhere that's away from the reference point, somewhere in the positive direction, it's heading back towards it or back towards the 0 point, right? The car is going to be here at time 0, right? And then let's say it's moving, right? So if it's moving backwards, right? So here is how you would mark that. Okay. So this car is moving backwards. That's good enough. All right. So we'll end the car's motion there. All right. Then if we're gonna grab our time markers, we're gonna mark this at time equals 0 seconds, time equals 1 second, time equals 2 seconds, time equals 3 seconds. Okay. And a lot of times when I make these problems, I'm not gonna actually include the time because you can tell the time by looking at which dots are which and looking at the arrows. So then yeah, you put the arrows in. Literally doesn't have an arrowhead. Why? Oh well, it's okay. I'll draw them in. Anyway, so you draw the arrows, and that's going to indicate the velocity. Okay. And in this case, the velocities are going to be negative. So this is a problem with a negative constant velocity, right? So starting here at somewhere in the positive direction. So let's say it's 20 meters away. Okay. That'd be fine. All right. Then we say, okay, it's moving backwards or negative towards the reference point. Okay. In this case, it's moving towards the reference point with a velocity of however many it's moving. So it's like a medium velocity. It's not super long, it's not super short. So some medium constant velocity. Okay. And that's everything I can show you about how to draw a motion map and how to interpret them.